Welcome back to another explainer. Today we are diving into a really fascinating source document from Leonardo US Cyber and Security Solutions, and it's all about the ELSAG SignalTrace intelligence system. We're going to break down this PDF in extreme educational detail so we can understand exactly how this surveillance technology functions under the hood. If you've ever wondered how modern law enforcement keeps tracking vehicles when the old-school methods just completely fail, well, you are in exactly the right place. Let's get right into it.
So think about this operational nightmare for a second. What happens when a suspect literally just takes off their license plate? Say a vehicle of interest is being tracked, right? But the driver pulls over, unscrews the plate, maybe slaps a stolen one on there, or just covers it up with mud. Suddenly, traditional tracking methods hit an absolute dead end. The visual identifier is just gone. So how do you track a ghost?
Here's our game plan for today's explainer. We'll start with number 1, beyond traditional license plates. Then 2, introducing the SignalTrace system. 3, the electronic fingerprint explained. 4, track devices and sources. 5, privacy and security measures. And finally, 6, law enforcement practical applications.
All right, moving into Section 1, beyond traditional license plates, the ALPR limitation.
To really grasp the new tech, we first have to define the old tech, which is ALPR, or Automated License Plate Recognition. You know, for decades, this has basically been the gold standard. Cameras on poles or police cruisers take these high-speed photos of passing cars, and they use optical character recognition, OCR, to read the letters and numbers. But here's the catch. It entirely relies on the physics of line of sight. Those cameras need very specific angles, they need decent lighting, and they need clear weather. If that visual data gets blocked by dirt, a physical cover, or honestly even just a really heavy rainstorm, the OCR software fails. If the camera can't optically see the plate, the whole system is completely blind.
And that brings us to the core paradigm shift we're talking about today. Traditional ALPR relies purely on the visual spectrum to read a physical plate on the outside of a car. SignalTrace, on the other hand, shifts the entire tracking process away from visual optics and into the radio frequency spectrum. See, while visual tracking relies on a piece of metal that you can easily swap out or hide, radio frequency data is beaming out from the devices inside the vehicle itself. You can unscrew a license plate in about 2 minutes, sure, but trying to hide all the digital signals constantly pinging from inside the cabin, that is a totally different, vastly more complicated technical challenge.
Let's jump into Section 2, introducing the SignalTrace system, bridging two worlds. The hardware making this possible usually looks like these white panel antennas mounted right alongside roadways. They act as a bridge, so instead of a traditional camera looking for light bouncing off a metal plate, these sensors actively scan the airwaves for ambient radio frequency identifiers as a car drives by. They are capturing those invisible, everyday broadcasts and merging the physical reality of the passing car with the digital reality of its electronic emissions. And the result? A glowing digital fingerprint.
The source document outlines how this just fundamentally alters daily operations. First off, it plugs right into an Enterprise Operations Center, or EOC. That means massive streams of raw RF data are flowing into one centralized hub for analysis. It identifies suspects by their unique device mix, and it does it entirely without needing a visible plate. But honestly, the biggest logistical win here is how cost-effective the coverage is. Since RF sensors don't care if it's pitch black outside, raining, or if the angle's a bit off, they can be deployed much more widely and way more discreetly than big, bulky optical cameras.
Okay, on to Section 3, the electronic fingerprint explained, the correlation concept.
Now, this is absolutely crucial to understand. We are not just talking about the system picking up one stray mobile phone ping. Not at all. The electronic fingerprint is a highly unique, trackable identity, and it's built on continuous algorithmic correlation. The system reads unique digital identifiers, things like MAC addresses or broadcast IDs, and mathematically calculates the probability of them belonging to the exact same moving entity over time. It basically marries the physical license plate data with these electronic identifiers to build a robust, ongoing profile for investigators.
Here is how it actually works, broken down into 3 steps. Step 1. Sensors detect publicly broadcast frequency activity. Step 2, and this is where the math is just brilliant. It tracks devices that consistently move together. Think about the physics of co-travel. If multiple totally distinct signals, like a smartphone, a smartwatch, and maybe a tablet, all hit sensor A at the exact same millisecond, and then those exact same signals hit sensor B 5 miles down the road perfectly simultaneously, while the algorithm mathematically concludes they aren't just random people walking by, they are bound by the physics of being in the exact same vehicle. Then, step 3, the system links this highly specific cluster of devices to a license plate and timestamped location data, cementing that electronic fingerprint. Which brings us to Section 4, Track Devices and Sources. The invisible web.
You might be wondering, what exactly is broadcasting all these signals? Well, we aren't just talking about your iPhone. Consider the sheer variety of everyday items that act as beacons just to do their normal jobs. Tire pressure sensors constantly broadcast RF data to tell your car's dashboard if you have a flat. Wireless headphones are pinging continuously to keep their Bluetooth connection alive. Key fobs are emitting signals. Even pet microchips are part of this. Seriously, if your golden retriever is happily sitting in the back seat, their microchip technically becomes part of your car's unique electronic fingerprint. This massive web of electronics creates a staggeringly distinct signature for practically every vehicle on the road.
Let's look at Section 5, Privacy and Security Measures, Operational Boundaries.
Now, to understand the system's operational boundaries, we are looking strictly at what the source document dictates. SignalTrace captures only publicly broadcast device frequency activity. The crucial distinction here is between metadata and payload. The document explicitly states it does not decrypt device content, and it does not store your personal messages or photos. It functions strictly as an identifier reader. Think of it like reading the tracking numbers on the outside of an envelope as it moves through the postal service. The system logs the routing metadata, but it is completely blind to the actual letter inside.
Finally, let's wrap up with Section 6, Law Enforcement Practical Applications, Actionable Intelligence.
So how is this actually used? These capabilities provide actionable intelligence in incredibly complex scenarios. It aids in detecting gang movements and uncovering trafficking operations by identifying convoy patterns. And why is this such a game changer? Because criminals might easily swap physical plates between cars in a convoy to confuse the visual cameras, right? But they cannot easily swap the digital signatures of 15 different smart devices spread among the drivers and passengers. The algorithm basically sees right through the physical disguise. Plus, it operates effectively in off-road venues, think rail stations, massive shopping centers, or big events where cars scatter and normal cameras just can't get a clean line of sight.
Identifies suspects by the unique mix of devices they carry or use. This exact quote from the source document honestly perfectly summarizes the massive fundamental shift we've been examining today. Law enforcement is no longer just tracking a physical 4,000-pound piece of metal. They are tracking the invisible digital ecosystem that is traveling inside of it. The vehicle itself is becoming almost secondary to the electronic fingerprint of its occupants.
I'll leave you with this final thought to ponder. As we constantly surround ourselves with more smart devices, smartwatches, smart tires, smart cars, how will the very concept of a license plate evolve in the digital age? We are rapidly moving into an era where your digital shadow is way more visible than a piece of stamped metal on your bumper. Thank you so much for joining me for this explainer. Keep learning, stay curious, and I'll catch you in the next one.